Okay, so we're going to do our corrections today. For our triangles here, so let me just move things around so that I can and get the timer going. Well, I guess timer doesn't matter because we have to go through them all anyway. Let's try and keep it under half an hour. Okay, so the first one here is the first question is for 6 drawn triangles, finding x using the tangent ratio. Okay, so the first one here we have our triangle drawn where we have 18 degrees, and then we have 12.8, and I think that was meters. I forgot to put meters in there. And we are going to solve for x. So the first step, I'm going to do these answers in blue here. The first step is, this is meters, is to identify our sides. Our angle's over here, so that's opposite, and this is adjacent. Okay, write our equation. Tangent 18 degrees is equal to opposite over adjacent, so x over 12.8 meters. Okay, so then we have to do algebra here, so we're going to multiply 12.8 meters on both sides. Okay, this cancels out, so we're left with 12.8 times tan 18 degrees is equal to x. Okay, so then we got to make sure our calculator is in degrees, and we take our calculator out, and we go 12.8 tan 18. So we get 4.158, so 4.2 meters. Is our x value for the first one. Okay, we look at our second one. Our angle is up here, 60 degrees. That's not 600, that's 60 degrees. So this would be our opposite side. And this would be our adjacent side. So we write our tangent. Tan of 60 is opposite, which is 16, over adjacent, which is x. So we've got to multiply our x out on both sides first to get rid of it here. So we've got x tan 60 equals 16. Then we've got to divide out tan 60 on both sides and cancel it. And we've got our solution at x equals 16 divided by tan 60. So if we do that on our calculator, we'll calculate it, make sure it's in degrees. 16 divided by tangent of 60. And I get 9.23 or 9.2 centimeters. Okay, that's our first two, A and B. Okay. Check your results that you got from last day that we were online. Oops, sorry. Next page. Okay, next two are C and D here. Now I noticed that when I released the sheet, I didn't put 19, but I put a note in the day when I released it that this should have been 19 meters, but I forgot to draw it in there. So depending on what you put in, hopefully you read the note when I posted it. So again, we're looking at this angle down here is 58, so we have to identify this is the opposite side. This is the adjacent side. Write it out. Tangent of 58 degrees. It's going to be the opposite side, which is x, over the adjacent side, which is 19 meters. Okay, so to solve this now, we multiply both sides by 19 to eliminate the 19, and we get the x by itself. So we've got 19 tangent of 58 degrees equals x. So our calculator comes out again. 19, 10, 58. Okay, remember, if you have a backwards calculator, you got to go 58, 10 times 19. I got 30.4 meters. .4 meters. Okay, hopefully you got my note about the 19. Okay, our next one, we've got two. We've got this one here, and our X is over here, and here is our 209 centimeters. So this is our opposite side. This is our adjacent side. Okay, now that we've recognized those two, we write tan 48 is going to equal our opposite side, 209, over our adjacent side, x. Oh, this is a two-stepper because the x is in the bottom. First multiplied by the x on both sides to get rid of it. So I got x tangent 48 degrees equals 209. Then divide out the tan 48 on both sides. Okay, when we do that, that cancels out. We get x equals 209 divided by tan 48. So we do that on our calculator. Okay, again, if you had a backwards calculator, you might want to figure out what tan 48 is first as a number and then divide it out. But if you got a forward one, you can just type in 209 divided by tan 48. And you can get 188.2 . Okay, and that was, I think that was centimeters, but I better check. Centimeters. Okay, there's D. Okay, our last two triangles that were drawn on the next page. Okay, so this is E and F. Okay, we've got 62 here, so this is our opposite side. This is our adjacent side. So we've got to recognize that it's going to be, I'll do it here, tan of 62 degrees is opposite, which is x, over adjacent, which is 8.8. Okay, so to get rid of it, we have to get x by itself, so we multiply by 8.8 on both sides. Okay, we've got 8.8 times tan 62 degrees is equal to x. Get our calculator out. Okay, again, if you're doing the backwards one, you go 62 tan times 8.8. If you're doing the front one, 8.8 times tan 62. 16.6 meters. Okay, our final drawing one, and then the rest are word problems, is F here, and that would be this one. Okay, so again, our angle is right here, so this is our opposite side. This is our adjacent side. Okay, so we're going to write tan of the 73 degrees is going to be the opposite side, 600, over the adjacent side, x. Again, the x is on the bottom, so we have to bring it over right away. So multiply it out on both sides. That gives us x tan 73 degrees is going to give us 600. Okay, and then we have to get the x by itself, so we have to divide out the tan 73 on both sides. Okay, and we're left with x is equal to 600 divided by the tangent of 73 degrees. Okay, so then we take our calculator out, and if we had a backwards one, it might be worth your time to do the tan 73 and then get a decimal number. If you got a forward one, you just type in 600 divided by tan 73 equals, making sure that you're in the right degrees on your calculator. So 183.4. millimeters. Okay, so that's all our triangles solved. Okay, hopefully you did okay on those. Check through them. Okay, so we do have 4 word problems, and I was a little tricky. I put one in there at the end with the angles on it from last section just to see if you could keep doing it. So the important part is drawing them. So we're going to do them one at a time. I'll flip ahead. So our first one is the tower is, I'll read it up. A tower is 21.6 meters high, and you are on the ground and look up to the tower of the tower with an angle to the top of the tower, with an angle of elevation of 39 degrees. How far away from the tower are you? Round your answer to the nearest tenth of a meter. So we're going to draw the ground and the tower here. So here's our tower. Right there. There's our ground. And you're looking up at it, and I'll use from where you are. And of course, you have to kind of assume that you're right on the ground. You're looking at it like this to the top of the tower. And what they're telling you is that there's a 90-degree angle here. So if we were to assume that the tower was a perfect straight tower like that at 90 degrees, okay, we know that the height of this tower is given to you at 21.6 meters. And they tell you that you're looking up at it with an angle of elevation of 39 degrees because you're sitting over here. And you're not sure what this is, which we will call X instead of a question mark because that's our tradition. You can put a question mark there. But so there's our setup. Okay, so then you got to identify, I want to find X. Well, that's the adjacent side. And this is the opposite side because we have this 39-degree angle. So we know that the tangent of 39 degrees is going to be the opposite side, which is 21.6 meters, divided by the adjacent side, which is unknown. Oh, X is on the bottom. So let's take it out right away by multiplying it on both sides. So X tan 39 is going to be the same as 21.6 meters. Okay, tangent 39 has to come out, so we get X by itself to solve for it. So we divide it out on both sides. And we have our solution that X is equal to 21.6 divided by tan 39, which we now plug into our calculator. Okay, so we go 21.6 divided by tan 39, making sure our calculator's in degrees. Okay, if you have a backwards calculator, it's a little bit different. You have to do the tangent and find a decimal before you divide. I got 26.7. So I'm 26.7 meters away from the base of the tower. Okay, and that answers our first one, number 2, the tower after the drawings. Okay, so let's keep going. We got 3 more to go here yet. Okay, so our next one is a ladder with ladder's base is 1.2 meters from a wall. If the ladder and the ground make an angle of 30.5 degrees, how far up the wall will the ladder reach? Round your answer to the nearest tenth of a meter. So let's draw our wall here and our ground. So say this is our ground. Here's our wall. Okay, there we have it. Okay, and we have a ladder in there. Let's make the ladder the dotted one so that we can kind of tell that it's a ladder leaning up the wall like this. And the angle on the bottom is given to us at 30 point. So it's kind of like a low one like this. Okay, and we know that according to this angle in here is 30.5 degrees. and it tells us that the distance the ladder's base is 1.2 meters, like that. Okay, so that's our problem setup. So again, we're going to have to identify what the values are. Okay, this is what we want to find, how far it reaches up the wall. We'll call that our x. So that means that's the opposite side, and this is our adjacent side. Do our tan of 30.5 degrees. Okay, that's going to be equal to the opposite side, which is x, over the adjacent side, which is 1.2 meters. So all we have to do is multiply by 1.2 meters on both sides. Okay, and we get 1.2 meters times the tan of 30.5 degrees equals an x. Okay, get our calculators out. 1.2 times tan, what is it, 30.5. Okay, I got decimal 706. So to the nearest tenth, it's 0.7 meters. Up the wall. Okay, and that is our third one. Okay, we got a fourth one with a power pole here, so we'll do that one as well. Okay, so it says, power pole has a guide wire connected to the pole at its top. If the wire is staked to the ground 9 feet from the pole, and the angle the wire makes with the ground is 71 degrees, how high is the pole to the nearest tenth of a foot? Okay, so let's make our pole here. Let's use a straight line tool. Let's use a solid line for that, actually. Okay, there is my pole. Okay, I'm going to put my wire and I'm going to stake it at 9 feet away at 71 degrees. So it's going to be pretty sharp like this. And here's our ground. Okay, there's our ground. There's our wire. Pole is right there. Let's label it so we can tell what everything is. Okay, this is our 90 degrees here. Okay, and it's telling us that this is 9 feet. And that this angle is 71 degrees. And they want to know the height of the pole, x. So if this is our angle in the bottom here, and this is 9 feet here, and this is our x here, this is our opposite side. And this is our adjacent side right along the ground. So we go tan of 71 degrees, okay, is going to be equal to, this is number 4, by the way, our opposite side, which is x, over our adjacent side, which is only 9 feet. Okay? Okay, oh, this one we just have to multiply 9 feet on both sides. Okay, that cancels these ones out, and we got 9 times tan 71 is going to equal x. Okay, so get our calculator out, make sure it's in degrees. 9 times tan 71. At 26.1, so it's pretty tall. 26.1 feet equals x. So that means our pole, or the pole, is 26.1 feet high. And I threw one in there, number 5, for finding an angle. So that was what we did in the first 3 days, just to see if you could remember how to do those ones. So we'll do 5. I guess we'll just flip the page here because that's what I've been doing. There we go. All right, so let's flip the page and we'll do the last one. Okay, the last one is you are 170 centimeters tall and you cast a shadow that is 289 centimeters long. What is the angle of elevation of the sun? Note this is a question from the last topic, finding angles. Okay, so let's draw this out. You are here. That is an ugly stick diagram, and you got some kind of neck there. Here's the ground, and you're making a shadow all the way out to here. Okay, and what happens is the sun shines down to give you that shadow, so it looks something like this. Sun is up here and it's shining down. Gotta get it right on here. There we go. Okay, so that's how the sun is up here. And we are asking for this angle. We'll call it theta. We don't know what that is. Okay, but we do know that you are 170 centimeters tall and that the shadow is 289 centimeters. Okay, so we do have to identify with this given angle, which side is which. This is our opposite side. This is our adjacent side. Okay, and we're assuming that you're standing parallel to the ground. Okay, so that would mean that the tangent of the angle is equal to the opposite side, 170, over the adjacent side, 289. So the tangent of the angle, theta, is going to be 170 divided by 289. So the 170 divided by 289, and you get 0.58882. Okay, and then we go tan inverse of that number, 0.58882, and that's going to give us the angle of elevation. So we go second function, tan on the calculator of that decimal number, depending if you have forward or backward calculator, and I get 30.5 degrees. So that's our angle of elevation for the sun. Okay, so the next topic that we're going to do is sine and cosine. And we're going to do sine first and then cosine. And we're going to just do a two-day method. So rather than doing angles and sides, we're going to do angle and sides together, because you know how to do angles and sides now with tangent. So we're going to do sine, that's going to be a 2-day thing. We're going to do cosine, that's going to be a 2-day thing as well. Then we're probably going to do some blended ones with everything together. That'd probably be a 2-day thing as well. And then do some word problems another 2 or 3 days. And that should take us to the end, somewhere in the middle of June. And that's probably as far as we're going to go for this year. Okay, so I'm going to stop here, and hopefully you did okay on those corrections. And just make sure you're checking your results and fixing your answers if you made some mistakes. Okay?